Robots by Elizabeth Tyndall. Robots around us. You have probably played with robot toys and have seen robots on television or in films. These robots probably look like people. Most real robots, however, do not look like humans at all. You may have seen one and did not even know it. Robots are found in many places, such as in factories and hospitals and on farms. Robots are machines that make life easier for people. They help us by doing tasks that are tiring or dangerous. In this book, you can read about the many things robots can do. Robots are unique. Robots are different from other machines. Most machines need a person to operate them, but a robot can perform a task automatically. A person programs a robot to do a task on its own. This is Hobo, a robot that can fight fires and work in dangerous places. These robots are being programmed. Each robot has a computer called a controller for a brain. A person programs the computer's controller with a set of instructions. The instructions tell the robot exactly what to do. Wires connect the controller to the robot's motors. The controller sends electrical signals to the motors through the wires. Then the motors make the whole robot or particular parts move. Remote control robots can perform tasks by remote control. A person gives the machine instructions from a distant location. Many machines in space are telerobotic, such as the Canadarm2. It receives instructions from scientists to release and repair satellites. What powers robots? Just like other machines, robots need energy to move. Energy comes from a power source. Batteries and solar cells provide one form of power. The electricity found by plugging an electrical cord into a wall socket provides another kind of power. Scientists first decide what a robot is to do. Then they decide which kind of power to use. Rechargeable batteries are portable and do not need power cords to work. They allow robots to move freely. However, batteries run out of power more quickly than most other power sources. This underwater robot, called AB, explores oceans. It runs on large batteries. This robot, called Sojourner, runs on solar energy. It was built to explore Mars. Solar energy, or energy from the sun, is another power source. Solar power is better for robots used in outer space because solar energy is unlimited. These robots must be careful, though, that their power is not cut off by shade. This can happen when another object, such as a planet or large boulder, blocks the sun's light from reaching the robot. Electricity supplied by power companies is another power source. A robot uses electricity when its electrical cord is plugged into an outlet. Robots such as these have a steady supply of energy, but they cannot move very far. Electricity provides the power for the robots in this car assembly plant. Robots on the move. Robots have changed over time. One of the major changes is in how they move. At first, robots used tracks and wheels, which only allowed them to move over smooth ground. Now robots can move in many different ways. When we think of robots, we often think of humanoids, which are machines that look like people. These machines often have 2 legs. Walking on 2 legs is difficult for robots because it requires balance. Scientists have found that designing a robot that can balance itself is very hard, so they have found other ways to make robots move. In 1865, a walking robot called Steam Man was introduced as a character in a book. Australian-born scientist Rodney Brooks observed how insects and spiders moved quickly and easily. Brooks and his team created Genghis, the first robot to move like an insect. Genghis has 6 legs like a cockroach. These kinds of robots have few problems balancing as they have several feet planted on the ground. Gyrobot. Gyrobot is a wheeled robot that was built to assist with the study of balance. The robot's computer program works with a device inside the robot to balance the robot as it moves. Genghis can easily move on different surfaces because of its 6 insect-like legs. Today, there are robots that can walk, shuffle or gallop, such as Asimo, Trudy and Scout 2. Scientists have also copied the ways fish move. They have made robots that move underwater. The robot Wanda wriggles through the water like a fish. Other underwater robots move by shooting out jets of water, like a squid. Asimo. Asimo is a robot that walks using 2 legs. It can walk forwards and backwards, turn sideways, go around corners and go up and down stairs. Wanda has flexible skin like a real fish. Thinking robots. Scientists are beginning to make robots that can think like people. These robots can solve problems. They learn from their mistakes and can adapt to their surroundings. They can even interact with the world around them. To do all of these things, robots must have sensors. The Deep Junior computer and world chess champion Garry Kasparov competed against each other in 2003. Elma. Elma is a 6-legged robot that can decide where to walk. Sensors in the robot's legs and head help it walk without running into things. Its controller allows it to learn from its mistakes. However, Elma forgets everything when it is turned off. Papiro robots use their sensors to move around a room and to communicate with people. Sensors in a robot are like a person's 5 senses. Sensors gather information about the robot's environment. They help robots see light and hear sound. Pressure sensors let robots tell whether objects are hard or soft. Built-in thermometers help them sense heat and cold. All these sensors let robots make maps of the space around them. Then the robots can decide whether they can follow someone's command. If a person tells a Zubit to turn right and a desk is in the way, the robot will ignore the command. Sensors let robots respond to people. Kismet is a robot head. It can sense when a person is too far away or move back if a person is too close. Kismet can talk and can show surprise, fear, happiness, sadness and anger. Ibwa is a robotic dog that also shows emotions. It uses sounds, body language and lights. If you pat its head, it makes pleasant noises and lights up. If it is tired, it lowers its head and slows down. Ibwa can do more than Kismet. Ibwa can sit, shake hands, fetch a ball and bark like a real dog. Working robots. Robots are especially useful for doing work. They can perform jobs that are not safe for people to do or that people do not want to do, over and over again. These kinds of jobs are ideal for robots. These women are inspecting food products made by robots. Robots in factories. Robots have been used in factories for many years. They help make all kinds of things, from cars to chocolates. Robots are very exact. They can do the same thing over and over and do it the same way every time. The robots most often used in factories are robotic arms. These arms have motors and cables to make them move. The tool on the end of a robotic arm is called an effector. Effectors can be finger-like grippers, drills, saws or even spray cans. This robotic arm can use a white-hot welder without getting too hot or tired. Robotic hand. A robotic hand can be made of basic machines such as levers and pulleys. A lever is a long bar that moves at one point. A pulley is a wheel over which a cable runs. The levers and cables are moved by motors controlled by a computer. Robots on farms. Many different types of farms use robots. Robots can make life much easier for farmers. The milking robot was introduced in the 1990s. It can milk about 60 cows in a day. Another tool that helps farmers is the intelligent hoe. It can remove weeds growing between rows of crops. A camera on the hoe works with a computer to let the hoe see the plants. Scientists are working on a robot that herds ducks or sheep. Robots in hospitals. Robots are used in hospitals. They carry supplies to patients and doctors. Some push carts through the hospital making deliveries. Robots are also used to help perform operations. RoboDoc assists by drilling holes in bones for hip replacements. Robots help train medical students. Students can practice performing robot-assisted surgery using a simulator or training device. The Helpmate robot. Helpmate delivers things like meals and medicine. It uses sensors to guide itself through a hospital. Helpmate can be programmed to go to any room and to use elevators. Robots to the rescue. Robots can do work that is too dangerous for humans. Some robots work with bomb squads to disconnect explosives safely. If a bomb explodes unexpectedly, the robot may be damaged. However, a robot can be fixed or rebuilt. Robot helicopters investigate accidents when fire or fumes make it too dangerous for a pilot. Robots can also crawl inside nuclear reactors. That is the job of Robug 3. It can crawl around unharmed in places where it would be dangerous for people to go. Robot explorers. Robots seem to be everywhere, even in outer space. Robots make excellent space explorers because they do not need oxygen, food, or water. They can travel to planets and locations that are either too far away or too harsh for humans. In 1999, scientists sent a robot called Stardust to explore a comet. Stardust will try to collect dust from the comet. Scientists hope Stardust will return to Earth with the comet dust in 2006. Exploring Mars scientists are using robots to find out more about distant planets. Robot Beagle 2 lander was sent to Mars in 2003. In 2004, NASA landed 2 robots on Mars, Spirit and Opportunity. Robots are useful underwater. The water pressure in deep oceans is too great for people. Robots can explore these underwater places much more safely. Some underwater robots, like Jason Jr., are connected by cables to ships or underwater vessels. The crew of the Alvin used Jason Jr. to find and explore the wreck of the Titanic. Other underwater robots, such as Autosub and Sea Glider, can move about freely. These robots collect different kinds of information. The data helps scientists to learn about life and conditions under the sea. Autosub was launched from the RRS James Clark Ross to measure ice thickness in Antarctica. Autosub is powered by more than 4,700 batteries. Scientists want to learn more about Earth, but some places are almost impossible for people to explore. Robots like Dante IL can do these dangerous jobs. In 1994, Dante IL investigated an Alaskan volcano. Scientists who were kilometers away used remote control devices to give it instructions. Dante 2 climbed the rough land with its 8 legs and sent information back to the scientists. NASA, the National Aeronautics and Space Administration in the United States, had Dante 2 built. NASA now knows more about volcanoes. Dante IL climbed the Mount Spur volcano to gather information about the inside of the crater. Future robots. Robots make life easier for many people, so scientists are continuing to develop new robots for the future. For example, they are working on the development of tiny robots that could perform surgery inside a person. Maybe one day we will all have robot helpers. We might have robots that walk our dogs, do our shopping, and help with our homework. Maybe one day you will think of a new robot idea. One day you may be able to watch a robot soccer match with life-size robots.